Okay, look, when we add these two functions, let's just be clear what we get when we add them. The function, the sum is going to be this. And then this, right? Well, it turns out that this gives us both this and this, doesn't it? Okay? So really, we don't have to do anything more to get this part of the segment. But now we got to do something to get this, right? And what's that going to be?
Yeah, that'll just be the same function shifted 2 units to the right.
Yeah, so we could shift this, where is it? This 2 units to the right. Okay? Which would give us what?
H of t minus 1 minus h of t minus 2.
That would be h of t minus 2 minus h of t minus 3.
Yeah.
We're going to shift it 2 units. You shifted it 1. In your RC circuit, that probably would have caused a fusion reaction or something, and you know, it would have been tragic. Or maybe not. Yeah. Okay.
It wouldn't do anything, would it?
Oh, it would change the solution to your system, but it wouldn't hurt anything. Depending on your, you know, maybe if I think about it, I can invent an RC circuit, an RLC circuit that it would have tragic consequences on. But
if you'd only shift it 1 to the right, it would just be 0 from then on out, right? Or no, it would just be 1
think
from
about
then
it.
on out. Yeah.
I'm not going to worry about that. I'm just going to say that now we've got. I mean, it's easy to think about. You can answer your own question on that one. Okay? So, what we have here is h of t minus h of t minus 1. Okay? That gives us this interval. Okay? If we shift this 2 units to the right, we have h of t minus 2 minus h of t minus 3. It should be obvious. Right? And then what?
Keep going.
Well, we got to keep going. There's a clear pattern to this, right? And what's the Laplace transform going to look like? Well, h of t minus 2 is going to give you 1 over s times e to the negative 2s, right? It's going to be plus that, and then minus e to the negative 3s. So the Laplace transform, we're out of time, so I'll write it. It's going to be this. You're going to get a 1 minus e to the negative s plus e to the negative 2s minus e to the negative 3s and so forth. What kind of a sequence is this?
Either a sine or a cosine.
You're thinking Taylor expansion.
Yeah.
Okay, so we'll see if that's fruitful. But I'm thinking it's geometric with a common factor of negative e to the negative s. It's a geometric series. With a common ratio negative e to the negative s. And you want to work out the details and make sure you understand that. So what's the sum of that series if you take it out to infinity?
0. Well, no, but it
No.
approaches 0.
The sum is, well, it's 1 over 1 minus r. Right? Common ratio. And r is negative e to the negative s. It's 1 over 1 plus e to the negative s.
And what is S?
It's the variable that takes you from the function domain, the differential equations domain, to the algebra domain. So you can use algebra to solve your differential equation, then transform it back. Okay? And you know, once you have command of that and this, that's about as deep as we're going to go into Laplace transforms. We're going to use it to solve some equations that are relevant to what we're doing in physics and real important. Okay? Whether they're in our specific syllabus or not, because I suspect they get touched on where you're going. Okay?